Hi everyone, for your information, everything around us, such as people, phone, and even the stars, is actually made up of tiny particles. They are so small, even we cannot see it by using the microscope. At first, scientists thought atoms were the smallest, but actually, atoms is made up of smaller parts. So, for example, when we break down the matter as much as possible, we will get the elementary particles. Let's think of it like Lego. Big Lego models are actually made up of blocks, and those blocks cannot be broken anymore. Elementary particles are like the smallest Lego pieces of the universe. They are the smallest known buildings block of nature.
Everything around us is made from matter, and matter made from very tiny particles. These particles come from two main, which is quarks and leptons. So we go for the quarks first. Quarks combine together to form protons and neutrons, which are found inside the neutrons of an atom. For example, one electron is made of three quarks. And then now it's about leptons. Leptons are another family of matter particles. A simple example is the electron, which move around the nucleus of an atom. And electron is a lepton, and it is not made of smaller particles. The diagram shows how quarks form protons and electrons, and how electrons surround the nucleus. So the key idea is simple. All matter is made from quarks and leptons. Bye-bye.
So, how does the particles interact? In the atomic scales, particles are interact using the forces caused by the force particles. The example of the force particles are photon and gluon.
Consider there's an identical messenger. Both of the messenger want to interact each other by one of them sending a message through them. Same goes to the electron. The electrons interact each other using the electrostatic forces caused by the photon.
Think of everything around you, your phones, the air, and the stars. If you break them down into the simplest ingredients, you will find the standard model. It's basically the estimate map or periodic table of every fundamental particles we know exist. The model is split into two main groups. First, we have the matter particles, the quarks and leptons. These are the building blocks that make up atoms. But particles don't just sit there, they need to interact. That's where the force particles come in. They act like messengers, telling the matter particle how to behave. It is not just a list, it's our base theory to explain how the entire universe works at the most basic level. It is a big picture of the reality.
Now, let's talk about the Higgs boson. In 2012, scientists discovered about a particle called the Higgs boson. This particle is very important because it helps explain why particles have mass. There is something called the Higgs field, and it exists everywhere in the universe. When particles move through the field, they become heavier. Now let's imagine we're walking through the water. It is harder than when we're walking through the air, so the difficulty is similar to the mass. So the Higgs boson was discovered using a large hadron collider, a very powerful machine. So this discovery helped complete the standard model.
Although the standard model is very successful, it is still not complete. It can explain everything in the universe such as dark matter and gravity. So, because of this, scientists continue to search for new particles and develop better theories. This research is not only important for understanding the universe, but also for improving our daily lives. For example, medical technologies like PET scans were developed from particle physics research. In the future, further discoveries in particles physics may lead to new technologies and a deeper understanding of the universe.